Okay, so hi everyone. Hope your preparation is going well. So let's see one question of basic elasticity chapter, that is for your strength of material. Okay, so this kind of question they generally ask for your 2 marks in your GATE exam. So most of the time these type of questions are generally formula based, but unless you know the concept, okay, uh, from where that formula has came, okay, what are the assumptions are involved, okay, then what are the consideration we have taken care in the while deriving the formula, those will help you. If you don't know, then this question may become hurdle for you. Okay, so let's see this question and how we can use the equation to solve this question. Okay. So the state of stress in a deformable body is shown in the figure. Okay, consider transformation of stress from xy coordinate, that means from this coordinate they are saying, to the capital XY coordinate system. Okay, that means they are transforming the stress system from this axis to this new axis. Okay, so be careful, they have given this small y and x, and they are talking about capital this y and x. Okay, so they are transforming the stress system into the theta, which is at a 30 degree from this small x axis, and they have assumed, they are already told, that the angle theta located at capital X axis, that means this one, is assumed to be positive when measured from the small x axis in counterclockwise direction, that means in this direction. Okay. So this is what they have given. Then they are asking the magnitude, the absolute magnitude of this shear stress component x, this sigma xy in MPa rounded off to one decimal place in xy coordinate system. Now you please understand the question, what this question they are asking. Then, so don't go into the catchy words statements they have given. Simply they are asking to transform the stress system. That's it. This is the question of the stress transformation topic. Okay, so now please focus on this, what question they are saying in the question, what they are saying. Okay, so now I'll draw this diagram quickly so that it can make you understand this properly. So this is the stress system they have given. In that there is a, so this is a deformable body. In that you have a sigma xx of 40 MPa. Okay, then they also given sigma yy of 35.6 MPa. Okay, now they are asking this quantity. In this they have given shear stress. This is what they are asking to compute in the MPa. Okay, with this they have also given in this plane, okay, or in this axis, if I can, pardon me if it is appearing something wrong. So in this axis, this which is they have given, this is capital X and capital Y. They have also given in this axis they have also given from this plane, okay, in the perpendicular direction, they have also given sigma xx. We will also call it as a sigma normal. This is 120 MPa they have provided, and this shear stress on this plane they have also provided. Let's write capital XY, which is 50 MPa. So this is what they have given. And now simply they are asking, don't complicate the thing, simply they are asking that what will be this quantity, as simple as that. Okay, so this is what they are asking and we will be computing this. Now there is a straightforward equation that if we set for derivation we can derive this, but we will not going to do that. There's a already derived the formula for the stress transformation at a whatever angle you want. Okay, at whatever angle, theta angle you want, you can do that. You can transform the stress system and you can find out the normal stress or the shear stresses, and this is what we are going to do. So we will do the derivation in the upcoming lecture. Okay, but as of now let's focus on this, how we can directly use that. Derivation is not important, directly formula and the what are the assumptions and the assumptions are involved to derive that, what are the consideration we have taken care, those are the important key points that you need to remember along with the formula. Okay, so let me do here this. Okay, okay, so there is a direct equation we have for the calculating the normal stress. So sigma normal, we'll write this as, okay, don't worry, I'll come to this, we need to calculate this. So let me do this first, then I'll give it to you. So this is the straightforward formula. If you go to any of the book of strength of material, You will find this formula in the stress transformation topic. I'll tell you what are the things are important while writing this equation. Okay, now please focus on this. Now this is your normal stress at a particular plane. That means here we have considered this plane. This is what they have given, normal stress. Okay. Now when you write this equation is derived for, now this is an important equation. You can have this in a formula sheet. Okay. Now when you write this equation, or when we have derived this equation, or you go to any of the book, this theta is derived for the clockwise direction. Okay, let me tell you this now. So this theta is derived in the anti-clockwise direction from the vertical. Okay, now what is the meaning of it? So let me write this first. This theta is for anti-clockwise direction from vertical. Now what is the meaning of it? Now please see this carefully. Here the theta they have given, it is in this direction. Okay, this is theta, and this theta is given this as a 30 degree. Okay, right? But in our formula, this theta is in anti-clockwise direction from the vertical. Now what is the meaning of this? This is our theta in our formula, this one. Okay, from the vertical and anti-clockwise direction. Okay, so this is our theta. Now what is this theta? Now this theta is, if it is 30 degree, then this will be, obviously this will be 60 degree, right? From now, this, in this equation, our theta is now 60 degree. Now this is the biggest mistake generally people do, generally students do, that what they do, that they don't know this formula from where this is coming. Okay, what are the considerations are involved? What they will do, directly they will pick this theta 30 degree, they'll put here this theta, and they'll get the answer, and that is wrong. The thing is, you should know that this formula is applicable for what, and that catchy point is that theta is derived for anti-clockwise direction from the vertical. This is also important. Okay, so now I hope, now this was a catchy thing they have given in the question also, that generally people, what they do, they'll pick the formula, directly substitute the values given in the question, and they'll get the answer, and that is wrong. Now that was the question, that was a catchy point. Okay, I hope now you understood. All right, now let's do the substitution. I hope now it is clear to you. Now this is normal stress, they already given in the normal plane, in the plane. Okay, which is your 120 megapascal. Now substitute all the values, sigma x, sigma y, everything is given. This is your, okay, now this is your sigma y and this is sigma x for the question, and theta we already know, theta is 60 degree. Then this is what they have asked us to compute, tau xy in this plane. Okay, I hope this is clear to you. Now do all the substitution. This is your 40 MPa. Now this is sigma x is a 35.6 MPa divided by 2. Okay, 40 minus 35.6 divided by 2. Just be careful, here we have a positive sign, then we have a negative sign here. Okay, then you have a cos, what will be, this will be 120 degree, 16 to 2. Okay, plus tau xy, that's what we need to compute, and sine, sorry, 120 degree. Fine, so this is what we need to do the substitution. All right, now let's do the simplification for tau xy. Okay, now if you see, I have already done this. Cos 120 will be 0.5. Okay, minus 0.5. Then sine 120 will be 0.866. Now you do the simplification, and let's do this. So this is 120 and this is 37.8, and now if you do this simplification, this is just negative of 1.1 plus tau xy 0.866. all right, now if you do this, tau xy will be equals to, you take this into this side, in the left hand side, and 83.3 divided by 0.866, and tau xy will comes out to be 96.18 ampere. Now please verify this whether you are getting this value or not. So this is the tau xy value. Okay, you can develop your own equation, while just you need to take care while deriving this formula, you need to take care and you consider this angle. Okay, that means in the clockwise direction you take your angle. and you do all the force balance and everything, and you get the this formula for the from the horizontal. Okay, you'll end up getting your own equation. And some of the book, in many of the book, they have already done this. Okay. Okay, so I hope now it is clear that the catchy point was that theta, taking care of theta, then this equation. Okay, I hope this is clear. So now let's meet in the next video. Probably we'll do the derivation. Okay, for this equation. Okay, all right. So let's meet in the next video, guys. Bye bye.